Have you ever faced a situation where you need to process messages quickly, but also want to keep them in order? It can be quite a challenge, right? If this sounds familiar, you're in the right place. Today, we're diving into how to process messages in parallel while preserving the order within conversations. I totally get it. When you're dealing with multiple messages, especially in a conversation, maintaining the order can feel like a juggling act. You're not alone in this. Many developers face similar issues when trying to optimize their message processing. Let's look at the specific question at hand. One user asked how to process messages in parallel while ensuring that messages with the same conversation ID are processed in the correct order. They provided an example with messages arriving in a specific sequence. Sound familiar? Let's explore this together. So, what's the core of the issue? The challenge lies in processing messages efficiently while keeping the order intact for those that share the same conversation ID. This is a common scenario in multi-threaded applications, and understanding it is key to finding a solution. And stick around. I have a great solution at the end that will not only solve this problem, but also enhance your overall message processing strategy. To begin solving this problem, the user should create a custom task class that extends the runnable interface. This class will handle the processing of messages while preserving the order based on the conversation ID. Next, the user should implement a mechanism to group messages by their conversation ID. This can be achieved using a concurrent data structure, such as a concurrent hash map, where each conversation ID maps to a blocking queue. Now the user needs to create a thread pool using the thread pool executor. This will allow multiple threads to process messages concurrently while ensuring that messages with the same conversation ID are processed in order. Finally, the user should implement the logic to submit tasks to the executor. For each incoming message, the user will retrieve the corresponding queue and submit the task to that queue, ensuring that the order is preserved. Fun fact, did you know that the concept of threading in programming was inspired by the way we multitask in our daily lives? Just like we juggle tasks, threads help us manage multiple operations simultaneously. Now, let's look at the answers provided by other users. An alternative solution involves using multiple executors to process messages while preserving order within conversations. Each message is treated as a runnable task. The user suggests distributing messages to different executors based on the conversation ID using a modulo operation. This way, messages with the same conversation ID are processed sequentially by the same executor, allowing for parallel processing across different conversation IDs. The user also highlights that while messages with different conversation IDs may not always execute in parallel, this approach effectively balances the workload across available executors. They provide a code example demonstrating how to implement this message executor, ensuring that messages are distributed efficiently. Now, let's see a response from a different user. An alternative solution proposed by a user involves using a unique mutex for each conversation to ensure messages are processed sequentially. This method utilizes a concurrent map to manage these mutexes, allowing for efficient synchronization. However, a potential drawback is that if conversations are short-lived, the number of mutexes could grow rapidly. That's the end of that answer. Let's see another perspective. An alternative approach involves using a single thread to receive messages and store them in an array list. After collecting a set number of messages, this thread pushes the list to another thread. This second thread sorts the messages by conversation ID and message ID. It then processes blocks of messages that can be handled together, using an executor service for processing. Any messages that can't be processed immediately remain in the list for the next round. Now, let's shift our focus to a different response. An alternative solution comes from a user who suggests using the Kafka Streams API. This API can help preserve the order of messages by utilizing partitions. While it requires a larger commitment than using an executor service, it could be beneficial, especially if you're already using Kafka. Now, let's shift our focus to a different response. This user suggests an alternative approach using 3 executor services. One service receives messages, another sorts them, and the third processes them. They propose using one queue for incoming messages and another for sorted messages grouped by conversation ID. The user also outlines the structure of their code, which includes classes for receiving, sorting, and processing messages. They emphasize the importance of sorting messages by conversation ID to maintain order during processing. Here's a pro tip. Always monitor the performance of your thread pool. Adjust the number of threads based on the workload to ensure optimal processing without overwhelming your system. And there you have it. By using a smart blocking queue and the thread pool executor, you can efficiently process messages in parallel while keeping the order intact. If you found this video helpful, don't forget to subscribe for more tips and tricks.